Let us continue to solve problems in concepts of physics. Three equal charges 2 into 10 power minus 6 coulomb each are fixed at the three corners of an equilateral triangle of side 5 centimeter. Find the Coulomb force experienced by one of the charges due to the other rest 2. Here we have taken that three charges are given. These three charges are placed at corners of equilateral triangle. Side length of the triangle taken as a 5 centimeter, and the charge of each charge value is taken as a 2 into 10 power minus 6. Now see here we know that force between coulomb between two charges acts along the line joining the centers of the charges. Since like charges are there, means then force will be acting radially outward. So here for this first charge, this second charge, this third charge. For force on third charge by first charge is in this direction, and force on third charge by second charge is the line joining 2 and 3 in this direction will be there. This radially outward. Now these two forces makes angle 60 degree because equilateral triangle. This angle 60 means this angle is also 60. To find resultant force, we know the formula. Resultant force is equal to F1 square plus F2 square plus 2F1 F2 cos theta. Here F1 F2 are equal because magnitude of the charges are equal and the distance by which charges are separated are equal. But here theta, by substituting theta is 60 degree, by substituting we will get resultant force as F is equal to F root 3. Resultant force is equal to F root 3. F is the force between two charges. Now let us substitute the value of F. F is equal to KQ1 Q2, Q1 equal to Q2, so that KQ square divided by A square into root 3. Now let us substitute K value as 9 into 10 power 9 and the Q value given 2 into 10 power minus 6. So 2 into 10 power minus 6 whole square into square root of 3 divided by 5 centimeter. Side length is 5 centimeter. So 5 centimeter means centimeter converted into meter, so that into 10 power minus 2 whole square. By simplifying this completely, we will get answer as how much means 24.9 Newton. 24.9 Newton. And this resultant force will be acting. The resultant force between these two F in this direction will be acting. Since these two forces are equal force, so that resultant force will bisect the angle between them. So that angle made by the resultant force with one of the force is 30 degree. So 24.9 Newton force acting at 30 degree with the extended sides from the charge under consideration. So at 30 degree in the line of extended 1 and 3, like that we can assume. Let us solve other problem. 4 equal charges, each 2 into 10 power minus 6 coulomb, each are fixed at the four corners of a square of side 5 centimeter. Find the Coulomb force experienced by one of the charges due to the rest of 3. Now we have to assume here 4 charges are there. These 4 charges are equal charges. These 4 charges are placed on the square corners of a square, like that we assume. This is the square. At each corner, one charge is placed. Q, like that is placed. Now side length is given. A is 5 centimeter. Side length is given. 5 centimeter is given. Now we need to find force on one of the charges. Let us assume this. Let us find force. We assume this is first charge, this is second charge, this is third charge, this is fourth charge. Let us assume. Let us find force on third charge by other 3 charges. Now fourth charge will experience force on third charge is radially outward. This F4 like that will be there. And second charge will experience force on third charge will be in this direction, that is F2 we take. And the first charge will be experience force diagonally will be acting along the line joining 1 and 3 in this direction. Force will be acting F1. Here magnitude of F4 and magnitude of F2 are equal. This F4 is equal to F we assume, F2 is equal to F we assume, because these 2 and 3 charges are equal, 4 and 3 charges are equal, distance by which is separated also equal is there. Now resultant of this F2 and F4 making angle 90 degree. If 2 vectors makes angle 90 degree, then resultant is equal to one of the force into square root of 2, like that we have to take. Now see here, now this F2 and F4 is there. Now this resultant will act along the F1, that is F root 2, because F4 and F2 are equal, makes angle 90 degree. So F root 2 is the resultant of F4 and F2, which makes angle 45 degree with the line joining 4 and 3 like that we assume. Now see here F root 2 and F1 are acting same direction, so that net force resultant force is equal to F root 2 plus F1. F root 2 plus F1. Okay, now F is the magnitude of force exerted by second charge on third charge. For that formula, kq square divided by a square into this root 2 let us take, plus F1 is the force experienced between first charge and third charge. For first charge and third charge force, we are writing kq square divided by distance, diagonal length is a root 2. Length of diagonal is a root 2. So that we have to write a root 2 whole square. Now, if from this, what we can take common in the sense kq square by a square we can take common into this root 2, this plus here 1 by root 2 square is 1 by 2. Now we are going to substitute the values of all the factors. K value is 9 into 10 power 9. Q is given 2 into 10 power minus 6 whole square. Divided by A is side length given 5 centimeter, that is converted into meter, 5 into 10 power minus 2 meter whole square. Into root 2 is 1.414 we take, plus 1 by 2 we take as a 0.5. This is take as a 0.5. By simplifying all this, we will get answer as 27.5 Newton, 27.5 Newton, and making an angle 45 degree, making angle 45 degree with the line joining 4 and 3. So net answer is 27.5 Newton, acts resultant force is 27.5 Newton at 45 degree with the extended sides of the square from the charge under consideration. Let us solve next sum. A hydrogen atom contains one proton and one electron. It may be assumed that the electrons revolve in a circle of radius 0.53 angstrom. 1 angstrom equal to 10 power minus 10 meter and is abbreviated as angstrom. With the proton at the center, the hydrogen atom is said to be in the ground state. In this case, find the magnitude of the electric force between the proton and the electron of a hydrogen atom in its ground state. Now let us find force experienced by proton on the electron. Let us assume this is the nucleus, in this proton is there, here electron in ground state revolves in the circular orbit. Now force experience we have to calculate. Force formula is K Q1 Q2 by R square. Here Q1 is charge of proton, Q2 is charge of electron, R is the radius of the first orbit. Now K value is 9 into 10 power 9. And this Q1 and Q2 are equal in magnitude, that is equal to E value, that is 1.6 into 10 power minus 19 Coulomb. By substituting the value 1.6 into 10 power minus 19, since Q1 and Q2 are equal, so that we are writing whole square, divided by R is the radius, distance between the charges is radius, that is 0.53 angstrom. 1 angstrom is 10 power minus 10 meter, so we have converted into meter, R square, so that whole square we are keeping. Now by solving this all, we will get answer as 8.2 into 10 power minus 8 Newton. 8.2 into 10 power minus 8 Newton we will get. Let us solve next problem. Find the speed of the electron in the ground state of a hydrogen atom. The description of ground state is given in the previous problem. Listen here. Here proton is there in hydrogen atom, electron is revolving in the first orbit. It is revolving in first orbit, so it will be moving with certain velocity. The velocity with which it tangentially moves is v. Now we need to find the velocity known as speed of the electron in the ground state we have to calculate. For that, it is moving in circular path, so that centrifugal force is required. The centrifugal force provided by electrostatic force between proton and electron. So electrostatic force between proton and electron provides necessary centrifugal force. Electrostatic force we calculated in the previous problem as 8.2 into 10 power minus 8 Newton. So let us substitute the value here. 8.2 into 10 power minus 8 is equal to centrifugal force is mv square by r. Now we want v square, so that v square is equal to this value 8.2 into 10 power minus 8 into r is 0.53 angstrom, 5.53 into 10 power minus 10 divided by m. M mass of the electron is 9.1 into 10 power minus 31 kilogram. This v square, by taking square root, we will get, by solving this one, speed of the electron we will be getting. The speed of the electron in the first orbit we are getting as 2.18 into 10 power 6 meter per second. 2.18 into 10 power 6 meter per second is the speed of the electron in the first orbit. Let us solve another sum. 10 positively charged particles are kept fixed on the x-axis at points x equal 10 centimeter, 20 centimeter, 30 centimeter, so on 100 centimeter. The first particle has a charge 10 power minus 8 coulomb, and the second particle 8 into 10 power minus 8, and third is 27 into 10 power minus 8, and so on. The 10th particle is 1000 into 10 power minus 8. Find the magnitude of the electric force on a 1 coulomb charge placed at the origin. Now let us solve this problem. Listen here. Here all the particles are placed in the x-axis. Let us assume first particle placed here, second particle, first charge is 1 into 10 power minus 8 coulomb. Second charge is placed 8 into 10 power minus 8 coulomb. Third charge is placed 27 into 10 power minus 8 coulomb. Like this, so on. 10th charge is placed whose value is 1000 into 10 power minus 8 coulomb. And here given that at origin charge is placed whose value is 1 coulomb. 1 coulomb. The distance of the first charge is R1, that is equal to given 10 centimeter. And the second charge is placed at given that 20 centimeter. And the third charge, third charge given distance placed is 30 centimeter. So on like this. 10th charge placed at a distance is equal to 100 centimeter. Now all the charges are positive charges, so that all the charges will experience force on the first charge. Force on the first charge is same direction will be there. In same direction force will be acting. In the same direction, F1, F2, all the charges will be force acting in same direction. F1, F2, F3, all the charges will be acting same direction, repulsive force. So net force is equal to algebraic sum, because all the forces same direction acting, so that algebraic sum directly we can take F1 plus F2 plus F3 plus so on up to 10th charge experience force. Now force formula we are going to substitute. Force is equal to first charge is KQ1 by R1 square. Second charge KQ2 by R2 square. Third charge KQ3 divided by R3 square plus so on KQ10 by R10 square. Now let us take common. KQ we take common, and Q1, Q2, Q3, this Q1, this Q2, Q3 is there. Now in this all 10 power minus 8 we can take common. 10 power minus 8 we are taking common. And here centimeter is there. 10 centimeter, 20 centimeter, 30 centimeter, 100 centimeter. 10 centimeter we can write as a 10 power minus 1. 20 centimeter we can write as a 2 into 10 power minus 1. And 30 centimeter we can write as a 3 into 10 power minus 1. 100 centimeter we can write as a 10 into 10 power minus 1, like that we can take. So the 10 power minus 1, if you take out in denominator, square is there, so the 10 power minus 2 we are taking out. So at last what is there means Q1 is how much, means 1 into 10 power minus 8, already 1 we taken out, divided by 1 square. 10 centimeter we have written, 10 power minus 1, 10 power minus 1 we taken common, and plus Q2 is given 8 into 10 power minus 8, that is 8 divided by R2 is 20 centimeter square, that is 22 into 10 power minus 1, we take in 10 power minus 1, so 2 square, plus similar way Q3 is given 27 divided by 3 square, plus so on 1000, 10th charge is 1000 divided by 10 into 10 power minus 1 whole square, the 10 power minus 1 whole square we taken out common. Now listen, we can cancel the common things here. 4, this 8 if we cancel 2, this 9, 27 if we cancel 3, like this, so on 10, this 1000 cancel 10 we are getting. Now substituting the value of K is 9 into 10 power 9, and the Q which is placed at the origin is 1 coulomb. Here 10 power minus 8 and 10 power minus 2 we are cancelling, so that we are getting 10 power minus 6 into 1 plus 2 plus 3 plus so on up to 10 we are taking. This is the sum of first 10 natural number whose value is 10 into 11 divided by 2, 10 into n plus 1 by 2. By simplifying all these, we will get the answer as 4.95 into 10 power 5 Newton. So for the sum, force on the particle which is placed at the origin by all the 10 charges is 4.95 into 10 power 5 Newton.